guys, so we are starting a new chapter. It's a new year, it's a new beginning. So, our chapter is going to be about matter and mass and weight and volume. So, before we just dive right in, let's do a quick review on the planets closest to the sun. So, if we were to list the planets closest to the sun in order, could you do that? So there is a saying that people say that help remember the planets of this closest to the sun. So you have my very excellent or eager mother just served us noodles. Okay, so you have the word sun down here. And if you were to list them, you would say Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So it's kind of hard to see. My handwriting's not the best. But you can just remember my very eager mother just served us noodles. So let's watch this quick video to help us remember the order of the planets.
There are 8 planets in the solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name is Mercury. I'm the second hottest planet, the closest one to the sun. A year on my surface is 88 days. I'm the smallest, but I'm lots of fun. My name is Venus. I'm the hottest planet, but the second planet from the sun. I'm the brightest planet in our solar system, and I'm too hot for anyone. My name is Earth. Not the planet you live on, the third planet from the sun. I'm the only planet with organic life, so take care of me, 'cause we're all one. My name is Mars. I am red in color. I'm the fourth planet from the sun. I have the highest mountain in our solar system, a volcano named Olympus Mons. There are 8 planets in the solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name is Jupiter. I am covered in clouds. I'm the 5th planet from the sun. My giant red spot is a raging storm. As for size, I'm the biggest one. My name is Saturn. I am brown in color. I'm the 6th planet from the sun. My outer rings are extremely thin. They're made of dust and icy chunks. My name's Uranus. I am blue in color. I'm the 7th planet from the sun. Humans have named me the icy planet because I am the coldest one. My name is Neptune. I am blue in color. I'm the 8th planet from the sun. I have too many storms in my atmosphere, and I'm the furthest planet from the sun. There are 8 planets in the solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun.
All right, so every single thing that is made up in the universe is made of matter. Okay, so then we have mass. okay? And mass is the size of things. So the mass of an object doesn't change, okay? It's still the same. The weight of matter can change based on the gravitational pull. So the gravitational pull is based on your closeness to the sun because of the gravity. Okay, so every single thing that has matter, the mass will stay the same on a different planet. The size is going to stay the same. Okay, anything that has weight based on the gravitational pull will change on different planets. So let's see what I'm talking about, okay? So I found this website where you can find your weight on other worlds or other planets, okay? So what you do is you can put in any weight. So this one has 114.4. Let's just say maybe you weigh 75 pounds, okay? You would enter your weight and then calculate it. Okay, so does a person's mass change based on gravitational pull? The size of a person, is that going to change based on how close you are to the sun? No. Okay, regardless of where you are, you have the same mass and you will take up the exact amount of space. Okay, your weight changes based on gravitational pull. Okay, so what I'm saying is if I were to go to the moon, okay, my mass would be the same as it is here on Earth. I'm going to stay the same exact size. Okay, my weight will look different because if I weighed 75 pounds on Earth, on the moon, I'm going to weigh 12.4 pounds. So my weight changes, but my mass does not. I'm still the same size, okay? So your weight changes because of the gravitational pull. Now, if you want to, you can go to this website up here and you can play around with it. It shows you the different planets, what your weight would be, the moons of Jupiter, and a couple stars, okay? And then you could read down here about mass and weight, okay? So, before we move on, what planet would we weigh the most on, regardless of our weight? If we weighed 300 pounds or 10 pounds, what planet would we weigh the most? Jupiter, okay, 189.6. Wonder why it would be Jupiter. So we know that Jupiter is the largest planet, okay? And the more mass, the bigger the planet, the more I would weigh. So let's just put another random number in here. Maybe we weigh 150 pounds. Calculate it. See, I'm still going to weigh the most on Jupiter because the size of Jupiter, okay? But I'm still going to have the same mass. I'm still going to be the same size, okay? All right, so we are now in our 5th grade book, which is the red one. So you guys can go through Clever and click on Science Book and go to the red one. And we are on pages 66 and 67 right now. Okay, so chapter 4, Why Matter Matters. So matter can be up in 3 states, a solid, a liquid, or a gas, okay? So this picture of ice shows water in 2 ways. A solid, which is the ice cube, and a liquid, which is the water. Water molecules also exist in a gas. Are there any other chemicals that can exist in more than one state? So think about it. Are there any other things that could exist in either a solid, a liquid, or a gas? So if we look here, gold is called an element. Unlike water, which is made of atoms of hydrogen and oxygen. So I'm going to circle that for us. Made of hydrogen and oxygen. So I know you guys have probably seen this before or heard this before. H2O. What is H2O? It's water. It's made of hydrogen and oxygen. Okay? So pretty simple. Hydrogen, there's two hydrogens and oxygen. That's how water is made. Now, if we looked at gold, it's made of only one kind of atom. Okay? So gold is made, if you look on a periodic table, the gold symbol is AU. We don't need to know that right now, but I thought that it would be a good thing to know. So just a typical day in your kitchen, water boils on the stove, freezes into ice in your fridge, and quenches your thirst as a cool liquid straight from the tap. How can water do all that? What are other things exist in nature that can be capable of such great feats? Explore an unseen world of whizzing, whirling particles and find the answers. So we're going to start learning about matter and mass and volume and weight in this chapter. And it can be confusing unless you pay attention to the definitions, okay? So we're going to be doing, when we get back to school, the in-person students are going to be copying vocabulary in their science notebook, whereas the online students will either keep it on a sheet of paper or in a Google document that they can keep going back to. So let's flip to the next page, 68 and 69, and the title is called Matter and Mass. Okay, so it's everywhere in everything, even in you. And they've got a picture of a person with their foot on a soccer ball and a chicken. What in the world? So what do the shoes on your feet, a barnyard chicken, the ice cream you hope gets served for dessert tonight, a soccer ball, and your best friend all have in common? They all are made of matter. Think of matter as a fancy word for stuff. A cloud, a dirty fingernail, a fire station, and a glass of orange juice are also made of stuff and therefore are made of matter. Does this mean that everything's made of matter? Well, not exactly. Ideas and actions like curiosity, friendship, Tuesday, hiccups, and being polite are not made of matter because they are not objects. Every object, whether it is as microscopic as your DNA or as huge as our sun, is made of matter. So, not everything is made of matter. If we read this sentence right here, does that mean that everything is made of matter? No. Ideas, actions, curiosity, friendship, Tuesday, hiccups, and being polite are not made of matter. Why? This right here. They are not objects. So if I were to say laughter, is laughter made of matter? No, because it's not an object. Is this highlighter made of matter? Yes, because it is an object. It has materials inside of it that makes it a highlighter, okay? How about this book? Is this made of matter? It is, because there's lots of stuff in it, right? Lots of molecules that make it what it is, okay? So if I said thoughts, are thoughts made of matter? No, because it's not an object. So any object is made of matter. Anything that's not an object, like laughter or thoughts or smiling, those aren't objects. So they're not made of matter. So let's take it a step further. So now we know that matter is stuff. So weighing in, a more formal definition of matter is anything that has mass and it takes up space. So if something has mass, it means that a force will be required to change its speed or the direction of motion. Okay, so if this was starting to roll on my hand, I had to force it to roll. If my hand is steady, it's going to stay still unless a force makes it move. Okay? So even if it is super small, a raindrop, a speck of dust, or an ant's eyeball, it is still made of matter. Mass is the word that we use to describe the amount of matter in an object. So let's read that one more time. Mass is a word that we use to describe the amount of matter in an object. So, people often confuse mass and weight, but they're not the same. An elephant and a car both have more mass and weight than a hamster and a skateboard. So we definitely know that they have more weight, because if you were to put it on a scale, an elephant and a car, it would weigh a bunch more than a hamster and a skateboard. Well, it also has more mass. It also takes up more space, okay? Because if you were to put an elephant and a car in a room, you would have almost the whole room taken up with space, or with no space left. Whereas if you put a hamster and a skateboard in a room, you would have more or less mass, okay? It would take up less space. So the reason it is easier to lift a hamster than an elephant is because the hamster has less matter in it. Because it has less matter, it weighs less. So the more matter, the more it weighs. Well, what is the difference between mass and weight? It all depends on where that elephant or hamster is in the universe. So if we were to put the hamster's weight in on that website, it would weigh less. It would have less mass than the elephant does, okay? So let's look at the difference between mass and volume. So this balloon takes up more space than the brick, therefore has a greater volume. Volume is the amount of space that a solid, a liquid, or a gas occupies. But the brick has more mass than the balloon because it has a lot more matter in it. More matter means more mass. Size has nothing to do with mass. Ping pong and golf balls have the same volume, but different masses. So if you were to put these two objects, the balloon and the brick, they both have matter because they are objects. Okay, if you were to put them in this very small box, the balloon is going to fill the box, whereas the brick might not fill it up all the way. So that means that the balloon has a greater volume. Okay, so the more space it takes up, the more volume. Okay, so the brick has more mass than the balloon because it has a lot more matter in it. It has a lot more stuff. Okay, so ping pong balls and a golf ball. Picture those two. They're about the same size, so that means that they have the same volume. But they have different masses because which one weighs more, the ping pong ball or the golf ball? The golf ball. So the golf ball is going to have the higher mass than the ping pong ball. Okay? So let's just go over some vocabulary before we move on. Okay? So matter is, let's circle it real quick. Matter is anything that has a mass and takes up space. Okay? So any object that takes up space and has matter is matter. Okay? Anything that has mass and takes up space is matter. Mass is the amount of matter in an object. So which is going to have a higher mass? A basketball or a tennis ball? Which one has a higher matter? Which one has the higher or takes up more space? The basketball. Okay, the next one is volume. So volume, let me erase that. Volume is the amount of space that a solid or liquid or gas occupies. Okay? So now we know what matter is, we know what mass is, and we know what volume is. So now let's talk about mass or weight. So the amount of matter in you does not change if you go someplace else. So like I was saying, if you take your body and you go up to the moon, your matter is not going to change. Okay, you're still going to be the exact same size. If you have a mass of 40 kilograms on the Earth, you would still have a mass of 40 kilograms on the moon. Basically, that's saying you're still going to be the same size. There is still the same amount of stuff inside of you. However, your weight would change. Weight is the measure of the gravitational pull on an object. So the greater mass of a planet or the moon, the greater its gravitational pull. So remember, Jupiter is gigantic. So the greater mass of a planet, the greater the gravitational pull. The moon has only 1/6 the amount of Earth's gravity because the moon is less massive than the Earth. So that is why you would weigh less on the moon, is because it's not as massive as the Earth. There's not as much mass. This means that everything on the moon weighs 1/6 of what it weighs on Earth. 40 kilograms is about the same as 90 pounds. So if you stepped on a bathroom scale on the moon, the scale would just show 15 pounds. So what you would do is you would take your weight and divide by 6 because it's 1/6, and you would get the weight that you would be on the moon. So here's another way to think about it. Pretend that on Earth you were able to lift a 50-pound box. On the moon, you could lift 6 of those boxes at the same time. Now let's blast on over to Jupiter. You still have the same 40 kilograms of matter in your body. So you still look the exact same. Your mass on Jupiter is the same as your mass on Earth, but Jupiter is much more massive than the Earth. It's a lot bigger. It has a stronger gravitational pull, so everything weighs about 2.3 times as much on Jupiter. There, your 90 pounds on an Earth scale would jump to about 213 pounds. So you would do 90 times 2.3 to get how much you would weigh on Jupiter. Of course, Jupiter is made of mostly gases, so you couldn't exactly plop a bathroom scale down and hop on. So let's look over here at the case study. So if you hop on an imaginary scale on every planet in our solar system, if a person weighing 90 pounds on Earth stepped on a scale on these planets, the scale would read Mercury would be 34 pounds, Venus 82, our moon 15, Mars 34, so Mercury and Mars, you would weigh the same. Jupiter 213, Saturn 96, Uranus 80, and Neptune 101. So that's just like that website that we used. It's just giving you, it's breaking it down for you in a case study. So now let's look at sink or float. If you drop a feather and a brick into a pond, why does the feather float and the brick sink? Well, if you said because the brick is heavier, think about the other things that you've seen floating on water that are much heavier than feathers, such as an aircraft carrier. And I know right here that it's getting ready to define what an aircraft carrier is because of this line. So an aircraft carrier is a ship that is so large that airplanes can land on it. So we've got a picture here of an aircraft carrier. So an aircraft carrier is definitely a lot heavier than a brick. So how can that big boat float? Think about it. Why would this brick sink? But this boat, which is ginormous, how does it float? Even though an aircraft carrier is really heavy, because it has a lot of matter in it, it takes up a lot of space, it is also really big. Takes up a lot of space. An object will float if its volume is large compared to its mass. So an object will float if its volume is large compared to its mass. So what that means is an object's going to float if it's taking up space, its volume is large compared to its mass. So a feather and an aircraft carrier do not have much matter in them compared to their volume. So they float. A brick has a lot of mass compared to its volume, so it sinks. So if you were to take two objects, say a rock and a tennis ball, and say that the rock is about the same size as the tennis ball, what do you think would happen if you dropped both of them into a tub full of water? If you dropped a rock the size of a tennis ball and a tennis ball in water, what would happen? So why would the rock sink but the tennis ball float? Think about that. See if you can answer that question. Think about why a rock the size of a tennis ball would sink in water, whereas a tennis ball would float. So what we're going to do today for our assignment is you have a Google form, Math and Matter. So you're going to read the following questions, look up the answer in our book because you can use your book, and select the best answer. So you have 9 multiple choice questions, multiple choice and fill in the blank questions that you are to complete after watching the video. Now, there's no way you can watch or answer this before watching the video. Remember, I can see now who is viewing the video. Have a great day.